Yeah, good afternoon to one and all. Myself, Dr. Ganesh Miriyala, Assistant Professor from the Department of ECE and MLR Institute of Technology. And I'm here to give the second classification. It is a system classification. In the system classification, we are going to be dealing in two ways. So one is the first one. In first method, we are going to be discuss about the up to time linear and non-linear systems. The remaining part will be covered in a second class. So first of all, what is mean by system? So generally, system is nothing but which takes some inputs and gives the output in general language. But if you come across the academic point of view, you can write the system definition. Is a system is a physical device or a process or a function which can takes one or more signals as input, which can take the one or more signals as an input and performs some operation based on the R requirement and produces the one output signal. So system is nothing but what? It is a physical device or process or it's a function which maps the inputs to the output function. So this function we are calling it as a system. So in general, here for the first one, y of t is a one system. Which is this is a transfer. Transfer means you can call it as a performance or you can call it as a function. So it operates this operator which is depends on the given input x of t. Based on x of t, it will perform the output. That means you will get the output y of t. And this is for the continuous signal. And second one, y of n. Y of n is a discrete signal. So y of n is a discrete signal. And similarly here also y of n is a output and y of n is the output and which is completely depending on the independent variable, that is x, x of n. So this is a transfer. So transform you can call it as. So system is nothing but which takes some input. Some means one or more. It can take the one or more inputs and produces one output. It can also, you can say it as a one or more inputs and it can also produce the one or more outputs also. It can produce the one or more outputs also. Here we can represent if we are taking is only single input. If you take single input and a single output, then this is called the seesaw systems. The seesaw systems is nothing but it will take only single input and it gives the single output. Similarly, single input it can take and multiple outputs it can give. Single input and multiple outputs. This is the first kind. Second one, it will take multiple inputs and gives the multiple outputs. MIMO system it is. So next one, it can take the multiple input and it will gives the single output. It is called meso system. Seesaw, SIMO and MIMO and MESO. These are the four kind of systems are there. So this is the definition about the system. System is nothing but it's a physical device or process which takes the one or more inputs and gives the one or more outputs. So next one will come across the system representation. How we are going to be represent a system. So in general, we can represent system in direct equation form. We can represent the system in direct equation form. Second one, it is a block diagram representation and mathematical representation. And fourth one, it is differential or difference. The both differential and difference equation. Next one, impulse equation. Or final, it is a transfer function representation, whether it could be Laplace transform or Z transform. So we will look into the one by one. Right, direct equation. Direct equation means you are relating input output in direct form. Like for suppose y of t is my input, is my output of a particular system. You are directly depending on the input whatever. For suppose the 2 is some gain and multiplying with respect to the input x of t. That means I am directly writing input is linear equations. That is a y of t is a output and x of t is a input which directly we are writing. There is no additional operations you supposed to do it. If you want to get the y of t output, you just multiply 2 cross whatever the input you are giving. Well, let us take x of t is equals to 5 volts. Then we are multiplying 5 volts which equals to 10 volts of signal you are getting. This is because it is directly related. There is nowhere of any additional operations are required for this direct equation representation. This is about the direct detection system. And next one we will come across the block diagram representation. The same system we can represent in terms of block diagram. So block diagram means you are taking one block. So this is a block represents one system. You are calling it as a H of t, and input is a X of t input and Y of t is a output. So this is the block diagram representation. So X of t is a input and Y of t is a output. Then this H of t is system function. System function. So then how you are interrelating the input and output? Y of t is equals to X of t convolution with H of t. X of t convolution with X of t. So this is a, since we are the function, what we are going to be do is we are representing in this block. So that's why we are calling it as a block diagram representation. The entire system will convert into the some mathematical equation. That mathematical equations will be placed in the block, that is called as a block diagram representation. Like next one is a mathematical representation. The same signal, if you want to write the Y of t, this Y of t or somewhere else V naught of t, you can call it as the same equation. So mathematical means there are so many mathematical tools are there, like logarithmic functions and integrations and differentiation, and so many mathematics. So if I want to find some like a V of t, integral 0 to t over I of t dt. So you are representing it in terms of some mathematical, or you can take one more thing, tan inverse of X of t. Whatever the function, but we are taking it as a tan inverse is a one mathematical function we are taking. With the help of mathematical equations, we are representing the signal. The Y of t is ultimately output. Y of t is ultimately output and X of t is the input. That what is the relation between this Y of t, X of t means that simply it is a tan inverse of X of t. So this is a one type of mathematical representation of the system. Next one, differential or difference equation. Differential equation means the same, you need to represent any system in terms of differential terms. Differential terms means, as you know, for suppose Y of t is my output and X of t is a input. So how you are relating the input and output relation? So that is, I can write it as a d power 4 into Y of t divided by dt power 4 plus 4 into, so 14 into d power 2 Y of t divided by dt power 2 plus 9 into Y of t, which is equals to some d cube by dt cube into X of t. This is a way of representation of the signal in differential equation. So this output Y of t and input X of t, how we are related, interrelated in terms of the differential equations. In terms of the differential equations, so that's why we are calling it as a differential equation representation. If you represent any system definition in terms of differential equation, that is called the differential equation representation. So this is, we can take it as a system example. Next, difference equation. So when I said d power something n into Y of t by dt power n, this is called the time domain. I mean, sorry, continuous domain. It is a continuous. Difference means it is for the discrete signals. Discrete signals, you can write it as a Y of n is equals to X of n plus 1 minus, or you can call, you can write it as in terms of Y of also, Y of n minus 2 minus Y of n minus 1. So the same one, Y of n is my present output, Y of n is my present output, and which is depending on the Y of n minus 2 and Y of n minus 1. That means 2 times block, 2 times back, and here it is 1 time block. So 2 times back and this is a 1 time back. So this is the difference between these two signals. Or you can write one more representation, Y of n is equals to same Y of n minus 2 minus Y of n minus 1. Next, it is a some plus plus x of n like this. So you are representing x of n. So these are the difference equations. First one is differential equation. So this is a difference equation in terms of discrete time signals. Next one, transfer function representation, which is in the form of Laplace transform. If I come across the Laplace transform and jet transform, we can represent the same system in Laplace transform and jet transform also. The system always we are representing in Fourier Laplace transform and jet transform, and the signal is representing in terms of Fourier transform. That means for a signal analysis, we are strictly using the Laplace transform. Fourier transform. Where it comes to the system analysis, we are using only Laplace and jet transform. See, if I write time domain continuous signal y of t equals to x of t convolution with h of t. So I am trying to represent in terms of a Laplace transform. So if I apply the Laplace transform for this signal, y of t is equals to y of s, which is nothing but x of t Laplace transform capital X of s. In time domain, if it is in convolution, in frequency domain, it will behaves as a multiplication. So then h of s. Transfer function means we need the h of s. Then h of s you can write h of s is equals to y of s divided by x of s. So this is the transfer function representation. Similarly, for the discrete signal, y of n is equals to x of n convolution with h of n. Or if I apply jet transform, y of z is equals to x of z multiply. Since it is a convolution is there, in time domain convolution means in frequency domain it is a multiplication, then you will get the h of z. Then here also h of z is equals to y of z over x of z. So this is also transfer function, or you can mention it as a system response in frequency domain. So this transfer function is in frequency domain, not in time domain. So if it is time domain, you should find the t or n. For continuous, you will find the t. For discrete, you will find the n. So here we are observing clearly only in terms of s and z only, z domain. So that is the frequency domain representation. Okay. Now, for example, if I written h of s is equals to 4 divided by s square plus 16. H of s is equals to 4 divided by s square plus 16. This is a one transfer function which represents the transfer function of a system. Let us take it as same. H of z is equals to, I can represent same, 4 by z square plus 16. This is also transfer function in z domain. These are the representations of the systems. One is a direct representation, means we are writing the directly in terms of mathematical equations. Block diagram representation means we are representing the system in block diagram form. Mathematical means any mathematical function which we are using for the trigonometric, logarithmic, or any additional terms we are using to represent the relation between the input and output, then we are calling it as a mathematical representation. Next, differential or difference equation. The same thing, the system we are representing, the system response we are representing in terms of differential equation. That means output and input we are interrelating with the differential equations. We are calling it as a differential equation representation. And for the discrete signal, we are representing the same term in terms of difference. Y of n equals to y of n minus 2 minus y of n minus 1, like that. That's next one, impulse response. Fifth one we left over it. So impulse response means this one only. If x of t is equals to the same, it's better to discuss the first one. Sixth one we already discussed. H of s is equals to y of s. So for this one we are finding what is x of s over there. If I used x of s, that means for x of t, first of all, if I use equals to del of t, x of t equals to del of t, then what is x of s? X of s means it is a Laplace transform of del of s. Laplace transform of del of s means 1. So now what is the transfer function? System transfer function. H of s is equals to system transfer function, this y of s divided by this x of s. X of s is equals to 1. That means if I say directly, I can represent when the input is impulse function, the corresponding response directly I can take it as a system response itself, the system transfer function itself. See, I write here, h of s is nothing but y of s divided by x of s. When the impulse response means the response when we are applying the impulse. Impulse means you can take it as a del of t function as an input. Then if you apply the Laplace transform, then del of t, Laplace transform of del of t equals to 1. Then h of s is equals to y of s directly. So that means whatever the system transfer function is there, that is the only system definition when the input is impulse. If you give the impulse function, the response itself is the system transfer function. That is the fifth one we require. Right? Next one, systems classifications. What are the systems classifications are there? One is a linear and non-linear systems, and time variant and invariant system. Next, causal and non-causal, and stable and unstable systems. Next, static and dynamic, and the next one it is a invertible and a non-invertible systems. So these are the 6 kind of systems we are classifying, and among those 6 classifications we are going to be deal with the linear and non-linear system for this lecture. Then the remaining will be discussed in the subsequent lectures. So to define a system, whether the given system is a linear or non-linear, the first condition, the system must be satisfy the additivity concept. Second one, homogeneity. If a system satisfies these 2 principles, then by default that system we can say it as a linear system. Then what is mean by additivity first of all? For suppose y of t is my output of a particular system and x of t is a input. So in this case, if I given some x1 of t is a input to the particular system, the same system, I am writing it as a sys. Sys means it is a system. Then I am getting the output is I am getting y1 of t. See, first of all we need to clear the what do you mean by additivity and homogeneity. Additivity means if a system is defined and its responses as y of t when the excitation is x of t, that means input is a x of t. For that kind of system, now first of all I am trying to give one input, that is a x1 of t, and I got the corresponding output is y1 of t. Next, second one, x2 of t I given, and I got the, for the same system I got the output y2 of t. If these 2 cases are exist, then I am giving the same inputs x1 of t and x2 of t combinedly I can give, and if I am able to give, and if I am able to find y1 of t, sum of those 2 outputs. Understood? So I am giving combining inputs, I should get this combining outputs. So if I give x1 of t, I should get x1 of t, x2 of t if I give an input, and I should get the x2 of t, y2 of t. So if I given combining, adding these 2 signals, if I given as an input to the same system, I should be able to write it as sum of the 2 individual outputs. Sum of 2 individual outputs. Then this is called, if this system satisfies this additivity, then we are calling it as a, this system is satisfying the additivity property, first one. Next one, homogeneity. If the same system x of t, if I given and I got the output y of t, x of t I given, then I got the output. If I multiply some constant a with this x of t, if you are getting output some a into y of t, then this principle is homogeneity, and the system is said to be following the homogeneity principle. Okay. So if any system satisfies these 2 principles, then you can say it as system, the particular system is a linear systems. So we cannot do always this additivity and homogeneity properties separately, individually. Then by combining these 2, then I can rewrite the same one, some a into x1 of t, some a into x1 of t plus b into x2 of t, a into x1 of t plus b into x2 of t. If I given this is the input to the same system, if I am able to write, if I am able to get the output a into y1 of t plus b into y2 of t. If I am able to get this one, then the system is linear. Here I written x1 of t, x2 of t, and I am adding this 2 also. That means additivity is completed. And a into and b into these two multiplication factors. That means a and b are the some arbitrary constant. Here also a is a arbitrary constant. So I am applying the additivity and homogeneity. Therefore, these two properties are satisfied. Then we can call it as a system is a linear system. We can call it as a linear system if any system obeys this rule. So then what is the title for this one? Individually, if I say it is additivity and homogeneity, by combining this additivity and homogeneity, we are calling it as a superposition principle. If any system satisfies the superposition principle, then we are calling it as a linear system. Is it clear? Next one, just take the same one, some a into x1 of t plus b into x2 of t. A into x1 of t plus b into x2 of t. Then for the same system, if I am able to write a into y1 of t plus b into y2 of t, if I get this one, then system is linear, else non-linear. This is the definition for the linear system. So let us take example. With this example, we will discuss it one by one. Suppose I define a system y of t is equals to 2 into x of t. 2 into x of t. So this is a one system which I given. Then find whether the given system is a linear or not. So for this case, first of all, we need to check the superposition principle. This is a superposition principle. This superposition principle we need to check. If the superposition principle is satisfied, then we can say the given system is a linear system. So apply let us take x1 is a output. When the x1 is a input, then what is the output? y1 of t. y1 of t is equals to 2 into wherever x of t is there, find the x1 of t. Write the x1 of t. This is a x1 of t. Similarly, x2 of t. Then what is output? y2 of t is equals to 2 into x2 of t. These are the two inputs. If I given x1 of t, I get the y1 of t, and x2 of t, then y2 of t. These are the two outputs we are getting, responses. Now I am giving combiningly some a into x1 of t plus b into x2 of t is a input. Now this time I am writing it as a y only. Y of t, which is nothing but, write the first two wherever the x of t is there. Here x1 of t you replaced with x of t, x2 of t you replaced with the x2 of t. Now this is entire input, this is the input, this is input, and now this is the input. So write a into x1 of t plus b into x2 of t. This is the entire input. So simplify this. Some 2 into a into x1 of t plus 2 into b into x2 of t. Okay. Now I can write this one, a into 2 into x1 of t plus b into 2 into x2 of 2 into b into x2 of t. If you look at this one, these two things, a into the same thing you can find over there, this one. These two are same, so that I can write y1 of t plus b into this one in square box, this 2 into x2 of t. Similarly, this square box 2 into x2 of t, this is a y2 of t. So if I applied a into x1 of t plus b into x2 of t for the same system, I can able to write the a into y1 of t plus b into y2 of t. So this case we can represent the same system which is satisfying the superposition principle, so that the system is linear system. The system is a linear system. We will take the another example. Same example I can take, y of t almost is equals to 2 into x of t plus some constant phi. So some constant phi. Similarly, do the same one. X1 of t is a input. Then y of t is a y1 of t is a output. Then 2 into wherever you find x of t, replace this input. First one x1 of t plus phi. Next this one x2 of t is my input. Now y2 of t is a output. 2 into x of t means x2 of t plus phi. So these are the two outputs. Now apply the combination a into x1 of t plus b into x2 of t is my input. If it is so, then what is the output? Y of t is equals to 2 into as it is, this 2 as it is, and x of t place means entire this input, a into x1 of t plus b into x2 of t plus 5 additional. Okay, now we can write 2 into a into x1 of t plus 2 into b into x2 of t plus 5. Okay, but if you check it, 2 into a into x1 of t plus 5, 2 into b into x2 of t plus 5. If I added plus 5, then I can write the minus 5. So for these two you can write, sorry, okay, fine. No, we cannot write actually, because if you find this term, then we replace the directly a into y1 of t, right? No, sorry, because we need to take the common from this one. We should have the two. We should have the true value. So it's very simple. What I mean to say, you no need to take this one, because we cannot represent any signal by since we have only one phi over there. To represent these two signals y1 of t and y2 of t, you need two phi's, additional two phi's. So we have only one phi. So it is not possible to represent this a into x1 of t plus b into x2 of t is equals to some a into y1 of t plus b into y2 of t, which is not equal. We cannot represent like that. Hence, then system is non-linear. So this is a non-linear system. So in general, so when we can say the fundamental rules to remember while deciding whether the given system is a linear or non-linear. All trigonometric functions, if you find the all trigonometric functions, if your input is in the following functions, like trigonometric, logarithmic, and exponential and power, these all terms, if your output will, if you find your input x of t in these functions, by default that system is a non-linear system. You should remember this thing. This is for the gate point of view. In gate, they will directly ask the questions in terms of trigonometric. For suppose if y of t is equals to cos h inverse of 2x of t plus 4. So if they ask, since it is a cos h inverse is a hyperbolic function, you can write one hyperbolic also. Hyperbolic function, then the system is a non-linear system. So what we studied till now, one is a system. What is mean by, first of all, system, and the system representation. In system classification, we studied linear and non-linear. So in next one, we will study time variant and time invariant system, static and dynamic, stable and unstable systems, causal and non-causal systems. non-causal systems. Thank you.